Hello everyone, this is Gaurang Raje from TE Electronics, and in this video we'll be looking at 3 op-amp circuits in LTSpice for macOS. So the 3 circuits we'll be looking at will include this linear equation solver, this subtractor, and this triple input non-inverting adder. To get started, open LTSpice either using the Spotlight search or through the Applications menu, then select Create a new blank schematic option here. In this window, we'll be creating our schematic. For the basic operations in creating the schematic, I'll be using the keyboard shortcut. So firstly, to select a component, you press the F2 key and then type in the component name. So we can type in the op-amp name and then we'll have the component. To place it, we just click on the screen. Then we can also move it by pressing the F7 key and then clicking on the component and then dragging it around. We can delete the component by using the F5 option. Once we have selected a component, we can also rotate it by pressing Command and R, and we can flip it about the y-axis using Command plus E. You can also deselect a component while you have selected it by pressing the escape key. Now to start with the actual linear equation solver circuit, we'll be considering this equation for the output voltage with these values for input voltages VA, VB and VC. First we'll place 2 op-amps. Then we'll place our resistors. Then we'll place our input sources. For that, type in voltage. This will be a DC source. You can zoom in or out on the circuit schematic by pinching on the trackpad, and you can move around the schematic by dragging on the trackpad. Next, we'll place the ground components. For that, press the G key. Next, we'll place the wires. Press F3 button. You'll get a grid like this, so you can just connect the components using the grid. Now for the rail voltages of the op-amps, we'll make a separate circuit beside this. So for that, select voltage components, which are DC sources again. We'll place 2 DC sources for VCC and VEE. Then connect these with a wire. And we'll ground the terminals of the DC components that we won't need. So the basic idea will be to use the positive terminal of this component for VCC of both the op-amps and the negative terminal of this component for the VEE. To connect these 2 components to the op-amp terminals, we'll use a label. Press the F4 key, type in the label name. I'll type in VCC. You can place the label multiple times. And similarly, I'll do it for VEE as well. We'll place additional labels for the input voltages and the output voltage. Now, to get the result, which is the answer of the linear equation on this schematic itself, we'll also need to place an output label which is used for DC bias point analysis. Go towards the output terminal of the whole circuit and right click on the wire. We can see the place OP data label, so select that option and you'll get question marks here. These question marks will be replaced by the actual value of VO when we run the schematic. Now finally we can set the values of all the components. Now the values of the other resistors, which are the input resistors for all the input terminals, the feedback resistances and the ROM resistors, will depend on this linear equation that we have. We need to tweak the values of the resistors so that we get these factors, which are 2, 3 and 5 for each of the input voltages VA, VB and VC. I'll first set the value of the feedback resistance. Take the value of the feedback resistance such that it is divisible by all the three factors. So for the input resistance for VA, I'll divide the feedback resistance value by 2 and make this 15K. The resistor at VB will become 10K. The resistor at VC will become 6K. This resistor in the center will have the same value as the feedback resistances. Finally, for the ROM resistors, their value will be the parallel combination of all the resistors connected to the particular op-amp, which is the feedback resistance and the input resistances. Finally, to run a DC bias point analysis, press the S key. In this window, we'll right click, help me edit, and go to the analysis CMD. Here we'll select the DC bias point option, click on OK. OK again. You'll get this .op label which you can place anywhere on the schematic screen. Now we can run the simulation. For that, right click and click on the run option. Here you'll also get an output window which we'll explore later. When you come back to this schematic window, you'll get the output voltage VO where we had placed the output label. If we want to visualize our results, we can use this window. We can plot a graph by going back to the schematic and then placing the multimeter probe on each of our input voltage leads as well as the output voltage. Whichever wires we click on, we'll get the voltage at those points on the graph. So here we can see that we get a result VO of -8 volts indicated by the graph. You can also right click and add the grid lines. For the triple adder schematic, I've made the circuit in a similar way and I've tried to model this equation which will give VO as the sum of all the three input voltages. I've taken the values of input voltages as 3, 4 and -2 volts respectively. In this circuit, I've connected the rail voltages directly to the op-amp. If we run the schematic, we'll get the correct answer of 5 volts. Finally, for the subtractor, I've connected one of the input voltages to the non-inverting terminal and the other input voltage to the inverting terminal. Here the output voltage will be VA minus VB with the values for VA as -3 volts and VB as -2 volts. If we run this circuit, we'll get the output voltage of -5 volts. So this has been a demonstration of the linear equation solver, the triple adder and the subtractor in LTSpice for macOS. Thank you.